an applications engineer with PHYTEC America. This week we're doing a YouTube series. We're posting a video every week. We're calling the series Cafe Yocto. We're going to be really focusing on PHYTEC's brand new product, the phyCORE-AM64x system on module and development kit, and how you can quickly get started with rapid development with this board and enable you to bring a potential product into the market in the future based on our system on module. So let's dive right into it. We're going to take a look at the development kit and do a quick unboxing. So this is what the development kit's going to look like. It's just in a nice brown box here. On the side, you'll have some information like including the default Linux release that's flashed to the SD card. We'll take a look at what that looks like. Some serial number information, the kit part number. We'll get into more of that as we go into. First thing I want to call out is this card. So when you receive your development kit, the first thing you'll want to do is go register your purchase of the development kit here at this link. Once you've done that, we'll actually release the schematics for both the system on module and the carrier board. The whole goal here is so that it enables you to develop and integrate the SOM into your custom designs. We actually encourage you to literally copy and paste known good circuits from the carrier board schematic to enable you to integrate your SOM faster and enable it to also have the highest chance of actually working when you get your first prototype units of your custom carrier board. Board bring up initially it can be very challenging, so the more you copy PHYTEC's known good circuits, especially when it comes to power and booting the system on module, you're going to have the highest chance of success of having a low number of PCB re-revs. So the next thing on this card here is the developer wiki. So we have the quick start that essentially I'm going to give you a video version of here today in this video. We have some other software guides, design documents like the hardware manual for the system on module. That can all be found here at develop.phytec.com. We'll actually be taking a look at that here a little bit in this video. And finally, too, we have a support portal. I and my team actually man this support portal. So if you have any technical questions, concerns, run into issues, debugging, if you're an existing customer and you're having issues with production, reach out to us here. Somebody will get back to you, including possibly me. Another cool side to this card is this side. PHYTEC is truly a global company. We actually manufacture all of our hardware out of Germany. Take that to the side, and let's take a look at the hardware. So this is going to come all in this ESD safe bubble wrap and bag. So we're going to take a closer look at the sticker here. A lot of this information was found on the side. We have the kit part number. Note here that this is an alpha development kit, so this is not suitable for production systems yet. It's still subject to change as PHYTEC, our hardware and software teams work together to iterate the design, get it to a stable place where we think it's suitable for production systems. We will remove alpha from the product number, the part number, and there'll be a part change notification to all our customers at that time too. And when you purchase alpha hardware with PHYTEC, you actually automatically get enrolled in our alpha program. So as we iterate the design, you don't have to worry about keeping up with the latest. We'll actually preemptively let you know in email, and then we'll send you the newest hardware, and you just have to ship us the old hardware back. It helps us support you by keeping obsolete, old, out-of-date hardware out of circulation. It really helps us in support. So actually, we'd encourage you to swap the hardware. It's something that we'll do for you free of charge if you purchase this alpha state hardware. It's just really to help you get started with development sooner. Another thing to mention here. So these are the part numbers for the SOM and carrier board. The .A1 is the revision of that part number, and so oftentimes you're going to want to look specifically at the SOM and the revision of that SOM to determine which version of software is appropriate. So if you're purchasing SOMs from us, PHYTEC produces these system on modules for 20 plus years. So as long as there's demand, we'll continue to create a footprint compatible SOM, enabling you to keep selling your product and without having to redesign it every time there's an EOL. That EOL just means end of life. It's a Moore's law thing where every few years the parts get smaller, and therefore you have old parts that go obsolete. We have to redesign our products to keep up with those changes. So PHYTEC will do that for you, and we'll just revise that part number revision there at the end. Let's get into the hardware itself. quick look at what this guy looks like. So the phyCORE-AM64x system on modules here, we can see that it is rich in industrial Ethernet communication interfaces. Everything that you need to actually operate this processor is on this system on module. So the RAM, you have eMMC onboard flash, you have an Ethernet PHY directly on the SOM. The power management is all handled here. So you really just need a carrier board to provide power and then bring out all the interfaces that you actually want to use in your end application. In this case, a reference design enables 3. You can have up to 4 or 5, something like that. That's all in the hardware manual. And then the SD card slot here. When you pull the dev kit out of the box, all the boot switches, which are found here, these are all going to be configured automatically to load software images from the removable boot media. This is really convenient for development, as you're able to iterate your software faster. You can just remove this, plug it into a host machine, get transfer files, update software, plug it back into your boot. So you can iterate very quickly with removable boot media. So that's why we've enabled that there. The main things that we're going to be using here today and in a little bit is the input for the power supply. This is the barrel jack, 12 volt 2 amp. And then across from it is the debug UART micro USB connector. So this one is not to be confused with the very similar micro USB connector on the opposite corner of the board. If you accidentally connect to this port, you won't get any serial terminal. And so every time you connect power, even if the board is booting, you will get nothing on this port. And this port actually provides access to the JTAG debugger, which is populated on board here, so that you don't have to have like an external JTAG debugger. It's pretty nice. So yeah, that's just to recap there. Don't confuse that port with this one. The one we want for boot and just basic functionality is across from the power supply. This is our serial terminal connector. Let's get into everything you need. Some things that come with the board, the development kit, is this SOM removal tool. This is necessary for safely removing your SOM. We provide these with each development kit so that as you work through development, and you might be working with a number of configurations. So these SOMs are highly configurable. You can change the amount of RAM they come with or the amount of eMMC. What we can do is we can fit this on the short side of the SOM. Be very careful of the components on the carrier board. You don't want to scrape around too much. Just be gentle. And don't work too fast. And we can just pry up one side and then pry up the other. And then slowly just kind of work up the SOM, and we can see that it just pops off really easily. So these are Samtech connectors. These are very high density, industrial, very rugged connectors. Across these two connectors, we have 280 pins. So this is a very dense interconnect. It enables us to bring out a lot of the features of the application processor from Texas Instruments, the AM6442. And then it enables a wider range of applications with the processor. So that's why we did it this way. Let's plug that in. Make sure these are keyed, so you can't force it on. You don't want to force it on the wrong way. You will damage those connectors. So just make sure it's correctly aligned. Typically, you want to avoid touching the top and bottom surfaces of these carrier boards. But for this video, we're going in formal mode. I'm just going to press down on those. That'll be fine. So now my system on module is seated. Let's take a quick look at what else is included in the dev kit. So we have an SD card reader. This will enable you to update the software on the SD card, power supply, micro USB, Ethernet, everything you need to boot. Let's pull this stuff away. And we're actually going to start working with the board itself. So pretend I pulled out my power supply. I have one prepared. Remember that the USB UART port is across from the power supply, so we're going to need that one. The first thing I recommend, don't plug in power. Let's set up our serial terminal first. So I'm going to go ahead and plug this in. This is connected to my host machine in Windows. I'm going to slide over here. And I'm going to pull up TerraTerm. So TerraTerm is a serial terminal emulator. There's a bunch of options. TerraTerm is a good one. That's my favorite, but a lot of people use PuTTY. If you're in a Linux environment, Minicom, you have your pick. And the setup for TerraTerm, it's very similar across these, but slightly different. I'm going to go to serial port, And here, you typically come up, at least in TerraTerm, you come up with some random port. I don't know what COM3 is. This is the first one that I get assigned to every time. But the nice thing about TerraTerm is if I select this COM port, I can see down here, I can see what drivers attach itself to the device. And this is a USB to UART bridge. So I know that this is my development kit, because I know that there's a part, this part in particular, is actually populated on the dev kit. And we're detecting that here. So the UART port is going to come up with 2 COM ports in Windows. Usually it's the first one. Depending on the development kit, it could be the second one. We usually reserve one or the other for Linux and the other one for coprocessors to talk to. In this case, what I'm going to do is I'm going to actually, this is a pro tip. I highly recommend it. So I open both. I open everything every time. Maybe that's a little too much work, but the nice thing here is if I now go to the board, plug in power, I'm immediately, and look at that, I was actually wrong. This coming up on the second port for this platform. I support a lot of products at PHYTEC, so it's different on all of them. For the most part, you're going to be working with one SOM platform, and you might have a number of configurations of that SOM. Maybe you might evaluate like the some processor from NXP on a SOM from PHYTEC versus maybe one from Texas Instruments, and you might compare their capabilities, but generally you're going to be focusing on development on one SOM at some point or another. So this is just a pro tip. Recommend opening both ports, and then we can just close that one out because we won't need it. And as we can see, we're booted into Linux. A couple other things I didn't mention as we did that real quick. The baud rate, 115200, 8N1, and no flow control. That is going to be necessary to communicate with all PHYTEC's products, not just the phyCORE-AM64x system on module, but that is the case here for this one too. So the login is going to be root, no password, and we're in. We could take a look around. It looks like this SD card was. This one is not really a default. There's a bunch of stuff on here. I was evaluating AWS Greengrass. We have actually a guide on our developer wiki on if you wanted to get started with AWS Greengrass. It's like a cloud service that you can very easily integrate into your any board that runs Linux. But we have the phyCORE-AM64x system on module. The carrier board development kit is actually codenamed Electra. That's why you see that here. We have this pre-certified with Greengrass, so this product is actually in the Amazon AWS product catalog for Greengrass-enabled devices. So what I'd like to actually walk into now is, now that we have this board booted, oh, and hey, remember when I mentioned that this is an alpha kit? So things are not stable with alpha kits, so you do not want to, this is a perfect example. I'm almost glad this happened. Just kidding. But, so yeah, this is a kernel warning saying that something dealing with the Ethernet PHYs has crashed. I believe I've submitted a bug for this in the past already. So once you get to a production stable design, you won't have these kind of issues. And if you do, you'd want to let me know. This is a known problem. I'm actually glad that it popped up just so I could show it off to you. So from here, I want to show that we have build tools like GCC, we have make, we have everything you need, including in Git. So you could just connect the board to the network. You could clone a project, get right into your application development right on the target directly. And so we're going to take a look actually at the developer wiki and show you where some guides are to help you get started. We're going to do that live today too. So here in our landing page for develop.phytec.com, the latest and greatest phyCORE-AM64x system on modules here at the top. So we'll take a click there. PHYTEC's product catalog is quite large. From here, actually, what we walked through in getting the board to boot was largely covered in the quick start. It's in much more detail. We talk about the specific boot switches that should be done or enabled right out of the box, but you could double check them here. The serial communication setup, some tips and tricks. You could use like your Windows Device Manager to help you identify specifically which COM port is which. Let's say you have like many USB devices plugged into your board exposing COM ports. This is helpful to help you narrow down which one is which. Setting up your serial port. This is using TerraTerm again, but PuTTY, there's other options. Logging in with root, and then how to power off your board safely. So now that we're booted, we can just dive right into development. Rapid development is PHYTEC's game. So let's go to the software development section and go to application development. We're actually going to cover this in a little bit, but I'm just teasing it. We're going to come back. We have cross compilation, an SDK for cross compilation available. It's pre-built. We'll get into that here in a bit. So in native development, we can develop stuff right on the target with those GCC and make tools that I just showed you. I'm just gonna copy this. Hello World. Hello World is a must. It is our first program, and we're gonna run it. Let's open a Hello World file. .c. Paste that in, and I can very easily just compile that. Easy peasy, rapid development.
Hey everyone, Des Archuleta here, Marketing Coordinator at PHYTEC. Thanks for joining us for our first video in a series all about our new phyCORE-AM64x Alpha 2 BSP. Stay tuned for what True has up his sleeve for the next video. And don't forget to like this video and subscribe to our channel so you don't miss out on any future content. And we will see you at the next one.